Okay, this is problem number 6. And it says, approximate the zero or zeros. So we're going to use this Taylor, Newton's method. Taylor's another person. It's kind of like the one we did in class, except it's x to the 5th. So let's think about it. See if there's more than one. Probably not, but so if we take the derivative, we'll get x to the 4th plus 1. And what this means is that you can't factor that, because if you solved it, set equal to 0, and you get x to the 4th equals -1, which has no solutions, no real solutions. So there basically are no minimums or maximums. That means it just goes kind of like x cubed, except it's x to the 5th. So it's going to have some, it's going to look very similar to a cubic, except it's probably going to be a little steeper because of the 5th power thing. So because of that, well, we still need to know what f prime of x is. And actually it wasn't just x to the 4th, it was 5x to the 4th, but it doesn't matter. Still doesn't have any real zeros. So I'm going to use the form in the book, their tables. So, and it looks like, you know, they need maybe 3 or 5 rows, one for the header, and then they have 1, 2, 3, 4, 5, 6 columns like that. And so we have n, we have x to the n, we have f of x to the n, x sub n, we have f prime of x sub n, we have f of x to the n divided by f prime of x to the sub n, and then we have the final answer, which will give us the new value of x. So move that and put it down there. So this is the subsequent calculation using the previous thing. F prime. Okay. And we start with the n equals 1, 2, 3, 4. And we want the difference between the x values to be less than 0.001, I think. Those 2 successive approximations differ by less than 0.001. So we have to come up with a guess. And again, because this thing is like x cubed, it's steeper, it's probably going to be either 0, we could either use x sub n equals 0 or x sub 1 equals 0 or 1. So let's use 0 would be the easiest thing to do. So let's just do 0. So when x equals 0, f of x equals -1. And when x equals 0, f prime of x equals 1. So the ratio of those two, -1 divided by 1 is -1. So if you take x sub n plus this, you'll get, actually you take x sub n and subtract this, so you actually get 1, which actually went to the other number that I was thinking we were going to use to start with. So let's just start all over again. Let's start with x equals 1. Okay, so now we stick it in here. So if we plug in 1 into this function, we'll get 1 plus 1 minus 1, which is 1. If we plug 1 into here, we'll get 1 to the 4th times 5, which is 5 plus 1 is 6. Take the ratio of those two, you get 1/6. And then we take this minus that. So let me find my calculator. Okay, so we get x sub n 1 minus So I get 0.83333, 0.8333, repeat. So here I get 0.8333, repeat. So f of x sub 1, we're going to plug in this value of x into there. So that's 0.8. So let's take, let me take the answer, 0.83333, raise that to the 5th power, add the answer, again, minus 1. So I get that the value of the function is 0.235. And if I plug the answer for x into the first derivative, I'll get 5 times 0.83333 to the 4th power plus 1, and I get 3.4113. I take the ratio of those two, 0.235 divided by 3.4113, and I get 0.0688. And I take this number and subtract that number, so it's 0.83333 minus 0.0866, and I get 0.7645. 0.7645. Okay, now I'm going to plug it into there, into the original function, so it's actually I can use my calculator, take the answer, raise it to the 5th power, plus the answer, minus 1. And so the value of the function is 0.02574. And the derivative, 5 times 0.7645 to the 4th power plus 1. I get 2.7080. And then I take 0.02574 divided by 2.7080. Yep. And I get 0.00951. And then I subtract that from that. And I get 0.7550. Slightly might need an extra column. Okay, so take that, raise that to the 5th power, plus that number, minus 1. And so f of x is 0. Actually, we'll do it in scientific notation. So it's 3.07 times 10 to the minus 4. It says continuing process until 2 successive approximations differ by less than 0.001, so we still haven't quite finished yet. Okay, 0.7550 to the 4th power times 5 plus 1 is 2.6246. Take 3.47 e to the minus 4 divided by 2.6246, and I get 1.3221 times 10 to the minus 4. $1.3221 times 10 to the minus 4. And I forget to write this number in, 0.07550. Okay, so take that number and add that to 0.7550, and I would get 0.7549. So the difference between these two is 0.0001. Yeah, so that looks like it's the answer. Let me just check the answer book. This is problem 3.8, number 6, 2.7. Yeah, they started at a different number. They started at 0.5 instead of 1, so they got 0.7553 versus 0.7549. Those are within 100 of each other, so that's good. Okay, this is number 7. So, what does this thing look like? Don't know exactly, but let's take the just trying to think about how we would have any idea where it crosses the x-axis. I mean, you could try some values of x. So this is x, this is f of x. If you could find a value of x, it's going to be close to, you know, it's the minimum number is 1, because you get 1 minus 1, which is 0. So you get 1 minus, this will be 0 minus 1, so f of x is minus 1 right there. And if you do 0, you'll get 3 times, well, zeros can't be that small, so we have to go to the next number. 2. So if we do 2, we'll get 2 minus 1, which is 1. Square root of 1 is 1. 3 times 1 is 3, minus 2, so that's 1. And there's no reason for it to go, well, I don't know. Let's just try another. It might loop back down again. So you get 3. Let's try an easy one that we can do, which would be 5. Because then they'll give us a perfect square. So we get 5 minus 1, which is 5 minus 1 is 4. Square root of 4 is 2. 3 times 2 is 6. 6 minus 5 is 1. And then if we try the next number, which would work out, would be 10. Because you have 10 minus 1 is 10 minus 1 is 9. Square root of 9 is 3. 3 times 3 is 9. 9 minus 10 is negative 1. So you can see that it goes, we have a 0 here and we have a 0 there. So we got to do both places. So since this is half, it would probably make sense to start at a half. And here it's probably going to be, again, choose somewhere in between 7.5. So if it was linear between these 2 points and this point, and this point, and that point, then it would be halfway. So that's probably a good place to start. So we have to make 2 tables. And let's see what size. So I'm going to make it 6 by 6 by 6. So this is n, this is x sub n, this is f of x sub n, this is f prime of x sub n, this is the ratio of those two. And then this is the x sub n minus the ratio. Okay, it's kind of small, but you know what I'm doing. 1, 2, 3, 4, 5. So we're going to start off with 0.5. And we need to find the derivative of this thing. which we rewrite it before we take the derivative. So you're going to have 3 times x minus 1 to the 1/2 power minus x. So the derivative, you're going to have 3 times, take the derivative of this, you'll get 1/2 x minus 1 to the negative 1/2 power times the derivative of what's inside the parentheses, which is 1. That's the chain rule on this thing, and then you have minus the derivative of x, which is 1. So what we get is 3 divided by 2 square root of x minus 1 minus 1. So that's the derivative of the function. So if we plug 0.5 into the original equation, we'll have 3 times the square root of 0.5. Excuse me, let me sneeze. Okay, so we get 3 square root of 0.5. Did I just 1.5? You might have been wondering why I did that. I don't know why I did that. And the reason I knew messed up because when I was evaluating the function, I was getting a negative square root, so I knew something messed up somewhere. Okay, square root of 1.5 minus 1 minus 1.5, and I get 0.6213. And the derivative, we 3 divided by the square root of okay, where was I? Okay, so we take 3 divided by the square root of, actually 3 divided by 2 divided by, again, the square root of x, which is 1.5, minus 1, minus 1. So I get a slope of 1.1213. Take the ratio of those two, 0.6213 divided by 1.1213, and I get 0.5541. And then I take 1.5 and I subtract 0.5541. That doesn't seem right. I get 0.9459, which is out of the domain. So, let's try it again. Now, sometimes these things can't converge, and that might be what's happening here. There's a convergence criterion. But first I have to see whether I did it right. Okay, f of x, 3 times the square root of 1.5 minus 1 minus 1.5, 0.6213, okay. Okay, f prime, okay, so the derivative is 3 divided by 2 divided by the square root of 1.5 minus 1 minus 1.12132. Take the ratio of those two, and you get that, and then you subtract it. So I'm going to check to see what's going on here. So they said the approximate zero is 1.146. They started with x sub n equals 1.2 instead of 1.5. So I think what's going on is that my original, I don't know how they came up with the original to be 1.2. So let's look at the graph of this thing and understand what's going on. So I'm gonna plot it here, and I'll show it to you. So you've got the function, which is 3 times the square root of x minus 1 minus x. So we'll graph that thing. Looks like that. You're like, oh, what's going on here? So I'm going to graph that thing. I don't know why that didn't show up. Let me try again. There we go. Magically appeared. And we had a page. So that's what the function looks like. And if I pick 1.5 and I draw a tangent line at 1.5, it's going to look something like that, which when you project that, you end up with a number slightly less than 1, which is what's happening to us right now. So the question is, what they did was they picked an answer of 1.2, which is about right here. And because of that, it stays within the domain. It's just convex nature to the whole thing. So if we take this, you can see if I'd chosen a larger number, I'd be even more off. So, 1.2 we're probably somewhere like that, and you can see it crosses over at that point. And then we can converge. So that is what's going on here. So we didn't make any mistakes. Just were sneaky about the original first guess. Now I was trying to do it without having to draw the graph to get the approximate starting point. So if we put 1.2 there instead, and then calculate all this stuff, we'll see what happens. Okay, so now we're going to plug it in, value the function. 3 times the square root of 1.2 minus 1 minus 1, or minus 1.2, and I get 0.1416. And 3 divided by 2 divided by the square root. So what I'm doing right now is I'm finding the derivative. So I get 1.2. I squared over 1.2 minus 1, and I get 2.35. Yep. 2.3541. Take the ratio of those two previous numbers, and I get 0.0602. And then I take that, subtract that, 1.2 minus the answer, and I get 1.1398. That's my new guess, 1.1398. And so you can see that it's in the domain. So now I do it again, 3 times the square root of 1.1398 minus 1 minus 1.1398. And I get negative 0.0181. And the derivative is going to be 3 divided by 2 divided by the square root of 1.1398 minus 1 again, and I get 3.0118. Take the ratio of those two, negative, so negative 0.0181 divided by 3.0118, negative 0.00600, actually 0.1. So I'm subtracting a negative number, so 1.1398 plus 0.00601, and that gives me 1.1458. And you can see I'm within 0.01 now, so I get 1.1458. And I go through one more time. So 3 times the square root of 1.1458 minus 1 minus 1.1458. So I get negative 0. Actually, let me put this in scientific notation. 2.87 times 10 to the minus 4. Slope is going to be 3 divided by 2 divided by the square root of 1.1458 minus 1 minus 1. So I get 2.9284. Divide those out, so I take negative 2.87 e to the minus 4 power. I divide by 2.9204, and I get negative 9.83 times 10 to the minus 5. And when I add that, I get 1.1458, and I add 9.83 e to the minus 5, and I get 1.1459. So you can see that's the answer.